Okay, so now we're going to have a look at exercise 009, which turns to come and look at cost of living indices, which we talked a little bit about over the last couple of weeks, and particularly with regards to the standard of living debate. And we're going to take a very simple example of this from one of the kind of earliest attempts to do it, from Bowley. And we're going to look at how you calculate unweighted and weighted indices. So I've just opened up ASC 140018, and if we look across the top, I've left some columns which we're going to fill in, but also years down here in column A, and then 5 different kind of components of Bowley's index, if you like, that together make up kind of his measure, if you like, of price indexes. Now, these are already in index numbers for you, with the base year set as 1900. So if we can check that, unlike the other example we had in class today, where there was a mistake in the original data, we can see that that's the base year set across there as 100. So the prices have already gone, these have already been converted, obviously to make them comparable, so we can see the change across the time. Let's start off though just by calculating a very basic unweighted, so just a simple average of each of those measures to come to our kind of index of the cost of living as a whole. So it's already an index, we don't need to worry about that. So literally all we need to do is to take the average, and we should know how to do that from a few weeks ago. And we're looking at from B13 across, that's the colon, to F13. Okay, close the brackets, and we're done. So just drag that down to apply here and do a quick check. Yeah, that's taking the correct average across there. Now, Bowley wasn't kind of claiming that each of these has equal, that food, rent, clothing, fuel, sundries should have equal importance in kind of coming to a measure of the cost of living. In fact, he explicitly intended to weight these items differently in the final calculation. So whereas we've given in this one here, each item effectively, by not specifying, we've given them all kind of equal weights in our average, to create most indices weight each component of them differently in terms of importance. Often this isn't a statistical decision, this is a kind of historical decision as to which have the greater importance in the cost of living when calculating what we would now call a composite index, just simply where you're kind of compositing these different factors together into one measure. You have to make a historical judgment about how you want to weight them, whether equally, or in this case, give 60% of the importance to food in the measure and only 4% over to sundries. Now, to create that weighted composite index, we simply need to design a formula that multiplies each index number by its weight. So we take one of these for this entry and we multiply it by its weight. Sums the results of doing that for each of these together for every year. And then divides that total by the sum of all the weights up here, which in our case neatly equal 100. In doing that, we're going to have to use some brackets to help ensure that each of those multiplications is calculated separately before they're then summed together. And then a further set of brackets that ensures that we get that total, if you like, before it's divided by the sum of the weights. So if we kick off by doing that in column H here, where we have a weighted composite index, let's give ourselves a nice overarching set of brackets opened up, and then start doing them for each. So let's take the cell B13, so we've got food there, and we're going to multiply that by its weight, which is 60. I'm not going to use an Excel reference here, I'm just going to hard copy it in. And then we want to add that to another set of brackets which do the same thing for C13, and we add times that by its weight, which is 60 in this case. We do the same, we add that again. Oops. D13, that would be times by 12 for its weight. The same again, E13 obviously, times by its weight. brackets times by 8, which is 4. So it's nicely clearing things in for us as we go. Okay, so to make sure we get the result before we do the division, we can close our first set of brackets up. And then we simply need to divide that by the sum of them. Now I could kind of get rid of the brackets, if you like, in these, and then I'll be nicely able to sum them to 100, but I know they go to 100, so we'll just have divide by 100 in there. And there we are, we've got our index at 115. So let's apply that down. There we are. And we can check that it's still an index because we've taken figures based on the 1900 figure. It's still an index, this, it's not done anything, it's compositing them together at different weights. And we still end up with 100 as our base year for 1900. So now what we've done is we've managed to weight these items differently according to how important we think they are. We come up with a composite index. And this is how you do this. This doesn't have to be food and rent and clothing and fuel. This could be, I don't know, public opinion about question number 1 you're interested in, about support for the Labour Party. Question number 2 for support for Labour, for kind of leftist politics in general. And you could decide, actually, I think most of our index we want to reflect whether people support the Labour Party, how they answer that question. And a smaller proportion of our index we want to see if they're left-wing in general. So this might be our kind of Labour supporting index, if you like, composite index, which takes in a number of questions that have been asked over time, compiles them together to get a more general measure of support for the Labour Party, just as another example. You could obviously change these weights as well, and that's what we're going to do in the second half of this exercise. Sometimes, though, you're going to want to alter the base year of that series. So at the moment we're at 1900. But that might not always be practical. Perhaps we need to view our data from a different perspective, because choosing that base year to base everything off of as kind of a percentage of that year affects how our data looks. We should try and, general advice, hopefully you read through Hudson, is to choose a year that's kind of general, kind of eyeball representative year, not one necessarily at the beginning or end of your series. In the middle is often a good choice. Essentially, if you chose an outlier, so something that was an extreme value in a data set, that comes with some risks, and it can, when you present it visually, can distort how your data looks. But more, more common, I think, is that we want to compare 2 or more published indices, say these ones here, and we didn't have kind of data for rent for 1900. We only had this data filled in, kind of primary data, if you like, so the actual figures were only in place for 1899. Then we'd have to choose that because we need a base year that all of our data we can access in a raw form. There can't be any missing. So we might need to, as we added a new column, let's say, I don't know, cars or something like transport costs, let's say, we'd have to, and we didn't have any data for 1900, there was a gap. We might have to rebase our data to 1899, let's say. Similarly, if we wanted to compare another index that we got from somewhere else, we'd if we're comparing the cost of living with a kind of employment index, we'd have to make sure that they were sharing a base here, and we could rebase to that. Now, sometimes, of course, you can go back to the raw data and just kind of reconstruct it, choosing a new base year, so go back to the actual price wages. But it's possible to simply kind of rebase from an index, so we can change what this base year is, just using kind of existing index data that we have. We don't always have to go back to the original kind of pound, shilling and pence, or whatever units the original data set was in. And we'll show you how to do that now by rebasing, without adding in any series, just rebasing the data we've got here to 1914 instead of 1900. So to do that, we divide each year's existing value by the existing value for our newly desired base year, and then we multiply the result by 100. So to show you up here, we'll take H13 So it's highlighted there for us, so what we currently got. And we're going to divide that by our new base year, which in this case will be column H, and it's got our base year, so we're going to fix this reference at H47, which is just off our screen down here. It's our new base year. And then we're going to multiply by 100. That gets us 105. If we drag this down, what we're hoping is that 1914 is going to be our new 100. Yes, it is. And what you've done there is convert from a base year of 1900 and convert it over to 1914. So that's an operation that, as you kind of gather more data sets and as you add extra measures into a new composite, you might need to do if you find that you can't kind of construct an index or a component index for your new measure, let's say transport, because you had an entry missing for 1900. Okay, your original base year.